Hello guys. Uh, we're looking at the new structure that we have for the Form 1s relating to additional mathematics. I would like to start a tutorial series on the additional mathematics. And relating to the additional mathematics, I mean the further mathematics, or what we call elective mathematics. So we'll be having series of tutorials relating to the topics, the new structure given by GES for the SHS 1. So if you look at the section 1 of the syllabus, you see that the section 1 deals with these three topics. We have binomial, we have binary operation, then we have the sets and its operations. So maybe I might not talk about all the topics, but I'll talk about the topics which students might have problem with. And one of these is the binomial theorem or the binomial analysis. So we're looking at the binomial theorem, and we look at what it's all about, the binomial theorem, the in-depth of all this. And this binomial theorem is not only in SHS level. You go to the higher level of education, you will still meet it. So I'll entreat everybody to take it serious and learn to understand the concept behind it, because there's probability aspect which we deal with binomial probability. For this level, in the higher level too, you'll be dealing with that. That's why I've already said that. So we'll be looking at the binomial theorem. But in case you have any challenges with any of the topics, let me know, and I'll find ways and means to assist you on that. It's a free tutorial sessions for the Form 1s. We're also doing the best we can also help our junior brothers and sisters understand the concept of mathematics and see how simpler and how easy mathematics is, only when you understand the concept and then the rudiment behind it. So my name is Mesa Kwabna Samuel, and I'll be your tutorial master in this section. So if you have any problem, let me know, okay guys? So we look at the binomial theorem as I've stated. So before we look at the binomial theorem, when you talk about binomial expression, we are looking at expression involving two terms. Example, but normally we use additions operation sign for these two expressions. Even though somebody can say I have, oh, a times b is also two terms multiplying. I have the first term and the second term is b. I have somebody can have, oh, a divided by b. Yes, it's also two terms because I have this. I also have a minus b, two terms. I have a plus b. Yes, good. They are all correct. I understand. But we are looking at, when you take this one and you give a power to this one will move you straight to indices. So it's easy to open this one, and this will give you a power 2 over b power 2. That's why we are not interested in this. And if you look at the product of the two terms, this one too, if you give power to it, it will still take you to indices. So it becomes easy dealing with a binomial of such form, because this will give you a power 2, then b power 2, as indices will tell you, based on the properties and the laws of indices. So we are not interested in the product of the terms, neither are we interested in the quotient of the terms, but we are interested in this form. This form is also like this form. I can write this as this form by writing a plus the negative b. This is a binomial. So most of the time when I see minus, you can also write it as this, as a plus negative of the next term. So this is what we are going to concentrate on. That is what we are interested in when we relate it to this theorem. So this is a binomial expression. So now, relating the binomial expression, we can have a case where I have a binomial a plus b, but the exponent is 0, or the exponent is 1, or the exponent is 6, or the exponent is a rational figure. I have a rational index. So this is the cases we will be looking at. So when we have cases like this, how do we expand this expression? So our main thing is understand the binomial expressions and how to expand the binomial expressions After the expansion, they will look at how we can use expansion to find approximate value of a given statement or a given expression, or how we can use the binomial theorem to what? To analyze problems relating to probability. So that is all that we'll be looking at. So we will not be spending much time, but as I said, everything is going to be simple. In case I am moving fast, to let me know, and everything is going to be easy. Mathematics is so beautiful and it's so easy to do it. So don't see it as a problematic. Don't see mathematics as a complex thing, even though you see it to be too complex. But the complex nature of it came by adding simple things together to form the complexity of it. So the complex nature is nothing. It all are deduced from simple things put together to form the complex form of mathematics. So it's very easy. So as I said, we'll be looking at, so we say, what is a binomial expression? Say a binomial expression is of a form like this, as I've explained. But here I only pick the n, the exponent. I say n is a real number. So I know you've done the number theorem. So in case you have issue with number theorem or numbers, we have real numbers, we have complex numbers, those things. If you have issue with it, we have rational numbers, we have irrational numbers, and then we have integers, those things. If you don't understand them well, let me know. I will give you a brief explanation on that one too. Good. So now example of that is this. I have 2 plus x exponent 4. I have 1 minus 3x exponent 6. So it means when I take the case of this, means my a is 2, my b is x, my n is 4. If I take the case of this, my a is 1, my b is negative 3x, and my n is 6. If you take the case of the 3 minus x or exponent 1 over 2, take the case of this, my a is 3, my b is negative x, and my n is the half. That's the 1 over 2. Good. So we look at the binomial expansion. What is a binomial expansion? Somebody will ask, what is a binomial expansion? Or when you say that a binomial has been expanded, what does it mean to have a binomial being expanded? So we say that when we write the binomial in series of terms, if I say series of terms, I'm going to explain the series of terms I'm talking about here. And if I were to write the binomial as a series of terms or in series of terms, then we say that the binomial expression has been what? Expanded. So in case you have anything you are doing based on understanding I have, by God's grace, is what I'm also giving. We have other good masters there. They have good ideas. They will also share with you when they also, I know when they also have the time, they will share with you. We are all helping build our nation, build our brothers and sisters for a better future. So based on my understanding and based on concept I have deduced from books, from masters, from professors, I want to simplify things. I don't want to go deep because we are in the SHS level, we are not in the tertiary level. So I always want to calm down. So in case I say something and it's too complex to you, let me know and I'll readdress it and come to the basic level or come to our level and explain it well in the detailed form for you to understand. Good. So I said that when we are able to write the binomial in series of terms, then we say that the binomial has been expanded. So I'm going to illustrate an example. So here, let's say we take this. Let me commit this sign. So let's say we pick a binomial. Let's say I have a plus b, all raised to the power 2. Good. So we know from basic level that if I write x power 2, indices will tell us that this is the same as x times x, right? Good. So if I write a plus b exponent 2, I can rewrite it as a plus b. Now, so you take that the a plus b or is your x times the a plus b. Good. Let me use this one. Let me use this approach to explain the series of terms that I'm talking about. So here, if I multiply, I know that this a will multiply this and this. A times a will be a squared. A times b will be ab, right? Then b times a, positive b times positive a will be positive ab or ba. Then if I write a, b, ba, they are the same because we know that multiplication is commutative. Good. Based on the commutative law. Good. So b times b will be b squared. So this will give us a squared plus 2ab plus b squared. This is what I mean, or what mathematicians meant by series of terms. So this is a term, another term, another term. So in that continuous order. So this is the series. The series take like a squared plus 2ab when the power is 2. When the power is 3, the series will change. When the power is 4, the series will change. The power is 5. The series is based on the exponent of the binomial. So we'll have different series relating to the power of the what? Of the binomial. So what I'm trying to say that the series of terms, this is a term. This term form a series, and this series were deduced from the fact that I have an exponent 2. So when the exponent is 3, it means we'll have a different series deduced. Good. So now here, that is what is meant by series of terms. So if I have been able to write this as series of terms, it means now this binomial has been expanded, and this is what you call the binomial expansion. So the expansion of this binomial is what we have here, or the expanded form of this binomial is what we have here. So now we are going to look at how do we expand a binomial with a given exponent. So in dealing with that, we'll be looking at the binomial and some approaches. So we'll be looking at the first thing we'll be looking at the binomial and the Pascal triangle. Then the second one we'll be looking at the doing the binomial expansion using the combination approach. Sorry, using the combination approach. Then you see I've written binomial theorem. So this theorem that you see, I'll write the theorem, which is a formula that we use in binomial expansion, and that theorem or that formula is deduced or was deduced by mathematicians through the combination approach. So I'll do the deduction, or I'll prove the formula, how the formula came by. I'll do the proofs of that one, and I'll do other series of proofs, because additional mathematics, you need to understand the origin of what we are using. You need to understand the concept behind it. If you don't understand the concept behind it, it makes it complicated or makes it confusing, because when we go to the application of this combination in probability or this binomial theorem in probability, since you've understood the concept behind it, how can we have this theorem? When you are using it, you understand how and when to use it, and use it well. Okay, thank you. So now we'll be looking at the binomial expansion in the Pascal triangle. So I'm going to talk about the Pascal triangle. So now, what is the Pascal triangle? So we said that the Pascal triangle is a triangular what? Arrangement of numbers. When you have a triangular arrangement, when you have numbers arranged in a triangular form, that is what we call a Pascal triangle. Was brought by Blaise Pascal. Is a great man. So I'm not here going to talk about the history behind what this man has done, this scientist has brought into this world, and the things we are learning. But what we have to know is Pascal triangle is brought by a mathematician and a scientist, a great man, Blaise Pascal. He deduced this Pascal triangular system, or this Pascal triangle, and this is an arrangement of numbers in a triangular array. So how does a triangle look like? It looks like this. So we are arranging numbers in a form like this. So I have a number here, a number here, a number here, a number here. The arrangement of the number forms a triangle, and that is the Pascal triangle. So how is it written? Normally, one thing I want you to know is when you are going to learn how we expand the binomial without doing the product of the binomials. So this thing I've done is using the product approach. So I'm writing this as a product of itself. So if there's power 3, I'm going to write it times itself, like this times itself 3 times. Power 4, I'm not using that approach. No, that's why we have the binomial theorem. We have all these cases there to help you understand expansion and how we expand it. So now I'm going to teach you how we expand it. And the Pascal triangle helps us to find the coefficient of the expansion. Like this one, you've expanded, you can see that the coefficient of the first term is 1. The second, this is the second term. Second term is 2. Coefficient is 2. Of A and B is 2. Coefficient of the B squared is 1. So now, the Pascal triangle will help us deduce the coefficient. After we are done with the expansion, then we put the coefficient, we fit the coefficient to the series of the terms. So now here, I'm going to write the Pascal triangle and explain how you deduce it. You don't need to memorize it. So it goes like this. So Pascal triangle moves like this. So let me create a triangle. Good. So at this, we always start with 1. I have a 1. Good. Now, when you check the left side of the 1, what is that? There's nothing there. So we are using the 0. There's 0 here. So now what we do is, we add these two numbers, the result, we put it in between, down. So 0 plus 1 is 1. So 1 comes down on the triangle. This plus this is 1, comes down like this. So now I am here, this row. At this row, what is here is 0. 0 plus 1 is 1, in between down. 0 plus 1 plus 0, the same thing. Now when you add this and this, 1 plus 1 is what? 2. So you get this. So when you come here, what do you think it will be here? It will be 1. You add this and this, 3. It comes. 2 plus 1, 3. 1 plus 0, 0. 1 plus 0 or 3, 1. 1 plus 3, 4. 3 plus 3, 6. 3 plus 1, 4. 1 plus 3, 1. 1 plus 3, 1. 1 plus 4, 5. 4 plus 6, 10. 6 plus 4, 10. 4 plus 1, 5. 1 plus 0, 1. So it goes in that. So you see that it starts with 1, end with 1. That is how it goes. It starts with 1, ends with 1. Now here, when I have a binomial A plus B, and the exponent is 0, you know that indices will tell us that any number raised to the power 0 is 1. And if you don't know the proof is simple. When you go to indices, the indices is in section 2 of the syllabus. The indices logarithm, and then indices logarithm and surd. I mean, if I say surd, S-U-R-D-S, irrational numbers, they are in section 2 of the structured syllabus, new syllabus. So when you go there, I'll do proofs. I said we do series of proofs. So don't worry, anything will be. I'll do the proof so that you understand why we say this, why we say that. Good. So here will give me 1. So now here, when the exponent becomes 1, when you open it, is still A plus B. What is the coefficient here? 1 is 1. That's the one you see here. So here, the coefficient 1, 1 is when the binomial exponent is 1. When the binomial exponent is 2, the coefficient form will be this row, 1, 2, 1. And I did the previous example, it was 1, 2, 1. When the exponent is 3, it's going to be here, which is what? 1, 3, 3, 1. So this becomes the formation. When it is 4, it becomes what? 1, 4, 6, 4, 1. So don't do iterations here. Okay, sorry for the word. So don't think like, oh, you are doing a football a formation, then you go and sit down and create something. But I know you can sit down and do the analysis and be creating it in your mind. Good. So now let's look at how do we expand the binomial, and we end today's tutorial session. When you meet tomorrow or in another time, we will talk about expanding the binomial, dealing with the binomial expansion using combination approach. And combination will do a lot of things. Good. So here, let's say I want to expand the binomial A plus B power. Let me start with the 2 like I did. So when I was doing the 2, I did A plus B. Let me use the product of the expressions to do it. Then I'll use the approach I am coming to use. So A times A, you had A squared. This gave us AB. This also gave us AB. B times B, we had B squared. And this gave us A squared plus 2AB plus B squared. Good. I'm really sweating. Yeah, I see that because of the bulb, the heat is too much. So, but don't worry about that. Just understand what I'm doing. So here, see that the coefficient is 1, 2, 1. Good. Now, this is how I'm going to expand it without doing this product of the binomial. So A plus B all squared. Now, this is how it goes. Now, the these two terms, A and B, they move together as products. So they are moving in the form of as products. So it means A and B are moving together like this. Now, in the course of the movement, or in the course of their transitions, what we do is that the first term will start by having all the exponents. So now here, the exponent of the A is going to be 2. So if A has taken all the exponents, and the exponent is 2, what will be the exponent of B? Nothing, 0. Now, in their successive term, so if I succeed, the next term that will move to, so in each successive term, whilst A exponent will be decreasing by 1 for each successive term, whilst for each successive term, the exponent of B will be increasing by 1. So what I mean is, if I move to the next term, so the next term, moving to the next term, the exponent of A is reducing. So it will decrease by 1, so 2 will move to 1. So I'm going to subtract 1 from the 2. Whilst the exponent of B will increase by 1. Good. So the next successive term, so now once A is decreasing, B is what? Increasing in the course of the transition, so in the course of the journey. So now the next term, A exponent will move toward 0, whilst B will increase toward 2. So I'm done, because start with 2, end with 2. So in the first term, you see that the first term of the binomial will have all the exponents, whilst the next term of the binomial will have nothing. And the secret that the product or the sum, the sum of the exponent result in the what? In the overall exponent. So now when you do the sum of the exponent, 1 plus 1 you get 2, 0 plus 2, 0 plus 2 you get 2, 0 plus 2 here 2 you get 2. Good. So now how do I get the coefficient here? It's by using the Pascal. So Pascal, I start with 1, here will be 1, 1, good. Here will be 1, you assume that there's 0 here, so 1, here will be what? 2, and here is 1. So I'm here. Here is when the exponent is 0, here is when the exponent is 1, here is when the exponent is 2, and the exponent is 2, so I'm here, so it's 1, 2, 1. So the coefficient of here is 1, coefficient of this term is 2, coefficient of this is 1. And that is what we have here. But we know that for 1 being a coefficient, it's not necessary, we don't have to write it, because we know that 1 is an identity element under multiplication. Because anything times 1 results in the thing itself. That's why some people say that, why is that we don't write 1 when it's a coefficient of a variable? We don't write it because by the identity law, it says that 1 is an identity element under multiplication operation sign. So anything times 1 is the thing itself. So that's why we don't write it. It's not necessary to write it. Okay. So let me use a Pascal to deduce a coefficient of this binomial. But one thing I want you to know is that Pascal has a limitation. Pascal cannot be used when we have a rational index. I mean, when the index of the binomial is a fraction, we can't use Pascal. So that is the limitation of the Pascal. It is limited. It can only be used when the exponent is not a rational index. Are we okay? Good. So let me take this one. Let's say I have example. I have this 2 minus x power 4. I want to expand this one. So using the Pascal, let me write the Pascal. So using Pascal, I'm going to have 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1. You don't have to worry yourself. Forget about the first number. You know, first number has to be 1. The second number will tell you which one you are dealing with. So the second number is 4, so it means I'm dealing with exponent 4. So I'm here, exponent 4, I'm dealing with this row. So the coefficient will be 1, 4, 6, 4, 1. So now let me do the expansion. So the expansion, I have 2 minus x power 4. So I'm starting. So the power of the 2 will be what? Will be what? 4. Whilst x power is what? 0. Sorry, it is minus x. So let me put minus x inside the bracket. 0. The next stage, now 2 will start decreasing for each successive term, whilst minus x exponent will be increasing for each successive term. So now the next term will be 2 exponent will go to what? 3. Good. Whilst minus x exponent will go to 1. The next 2 exponent will go to what? 2. Whilst minus x exponent will go to 2. Next, 2 exponents will go to what? 1. whilst minus x exponent will go to what? 3. And the last 2 exponent will go to 0. I won't write it. Okay, let me write 2 is 0. Whilst minus x exponent will go to what? 4. Now I'm putting the coefficient. The first coefficient is 1, so I won't write. Second coefficient is 4, so it's here 4. Third coefficient 6. The next coefficient is 4, so it's here. Last one is 1. I won't write it. Good. So now, if you look at it, your answer will be like this. Look at this. So your answer is going to be, so 2 minus x exponent 4 is going to be here 2 power 4, because x, this is, any number for 0 is 1, so I don't need it. So plus 4 times, okay, let me write the 2 power 4. You know 2 power 4 is what? 16. So 4, this 4 times 2 power 3, which is what? 8. 8 times minus x. Because the power is an odd number, it will still result in the negative. 6 times 2 power 2 is 4. Now, minus x exponent 2 will be positive. So it's a positive x squared. Good. The next one, I'm going to have, here, 4, 2 times 1, minus x power 3 will be still minus x cubed. Good. Let me clean this one. Then the last one, 2 power 0 is 1, gone. Minus x power 4 will be positive, so positive x power 4. So your final answer will be 16. This times this will be negative 32. X. 6 times 4, 24. 24 x squared. This times this minus 8x cubed plus x power 4. So this becomes your expanded binomial. So this is how we use the Pascal, and we'll end today's tutorial at this time. So hope to see you or meet you on the next tutorial session, which will be the binomial expansion using the combination approach. Thank you. If you have any problem, if you have any suggestion, if you have any contribution, let me know. In case you don't see my board too, let me know. In case my handwriting is small, let me know. I'm Sakabna Samuel. They called me Ayok for short. Thank you guys. God bless you.